We ready, guys? You're not ready? Get ready. Okay. So we are moving on. 1.1 day 3. We're going to spend a total of 5 days on 1.1 because there's some things we got to go back and we got to refresh our memories on. Do you need a pencil, Corey? The blue little cup on my desk. You can have it. Well, not the cup, but a pencil out of the cup. It's not yours. Okay, so 1.1 day 3, we're going to talk about writing and solving one-step equations. Jaden, can you close your laptop for me? Thank you. So a couple things to remember. When we are solving equations, what kind of operations do we use when we're solving equations? Alex? Well, we should, yeah, we occasionally need to use order of operations. What else? So like if we're trying to get x by itself, Jaden? Opposite operations. But order of operations, when we have more complicated equations, we'll have to use that as well. So we want to use or do the opposite. Oops, sorry, the stylus isn't working. Do the opposite operation to get the, what are we trying to get by itself when we solve? What's a fancy word for the letter in our equation? Dallas? The variable. To get the variable by itself. Good. So, and Aiden, yeah, you can use X. The letter's just not always X, but you can call it that if you want. So for example, and we're just gonna, and I know 4 is blank, we'll add one in. I just accidentally goofed and made a typo there. We're just gonna quick recap on solving our one-step equation. So Alex, hopefully this helps you. I think this was that day you missed, the day you slept in. So if you take a look at number 1, we got x plus 7 equals negative 12. We want to get our x all by itself. So what opposite operation would we do to make that happen? Lynn? Yep, we would subtract 7 from the left and the right. And you're going to have x equals, I'm sorry? That would be if it was positive 12 minus 7. Close. It is going to be negative. Now, something that I mentioned is always add same signs. Don't we have a negative 12 and a negative 7? Yeah. So if they're both negatives, think of it almost like always add same signs. What's 12 plus 7? 19, but they're both negative, right? So it's negative 19, exactly. And that helps sometimes if you get a little confused on your addition and subtraction with negative numbers, okay? That's just sometimes a helpful way to look at it. Number 2, we have 6x equals negative 30. We got to get our x all by itself, but I'm a little confused. I don't see any addition, subtraction, or multiplication signs. All right, do you see any little like things, Asia? What does this mean? What do I do? Right, this means 6 times x, right? When you don't see something there that's multiplication and the opposite of multiplication is division. So divide both sides by 6. Good one. So divide, and what's a negative divided by a positive, Dallas? A negative, and then 30 divided by 6 is? Jaden? 5. And if you guys struggle with your mental math on little things like that, that's okay. A lot of the times it's to be expected. Whenever you guys are in the room, you're always welcome to one of my class calculators, okay? If you use it though, don't put it back in the slot. Put it in that little box underneath so I sanitize it later, okay? But don't guess. If I feel like you're guessing, I'll just make you go grab a calculator. But right, don't guess. There's no need to. That's how we make silly mistakes. So number 3, We got x over -4 equals -4. What's this little fraction bar mean? It means divide, and what's the opposite of dividing? Multiplication. So we are going to multiply both sides by -4. Right, our -4 is on the left, will cancel, and x equals, what's a negative times a negative? A negative times a negative is a positive. A negative times a negative is a positive. And 4 times 4 is 16. So this would be positive 16. Good. And again, guys, if you're not sure, especially if we had a little bit of bigger numbers, plug it into a calculator, right? Then that's okay. And number 4, I'm going to make up another problem. We're going to do, how about -5 plus x equals -21. Because why not? -5 plus x equals -21. Now I'm giving you guys something like this because it's just a touch trickier. And what makes it just a little bit trickier is on the left, right? Or I guess for you guys this side, isn't there a negative sign and a positive sign? So it's like, okay, well, which one do I do, right? Well, think about what we talked about the first day. What's always more important, a negative sign or a positive sign? A negative. And the reason that is because negatives change things, right? If you have a positive and a negative, it's a negative. If you have a negative and a negative, it's a positive, right? Negatives change things up. So think about it this way. If you looked at this and you go, oh, well, I have -5 plus x. The opposite of adding is subtracting. So don't write this down. But what if you're like, okay, I'm going to subtract 5. But isn't the objective to get that -5 to cancel? Right? It's to get rid of it, right? Will a -5 get rid of another -5? No, it'd become -10, right? That's not what we want. Lynn? We have to add 5 instead. Very good. So this should actually be adding 5. Good. And then you'll have x equals excuse me, -21 plus 5. So with this, you know how I said we should always add same signs? Right? Are these the same signs? No, so instead think of it like subtraction. What's 21 minus 5? 16. But in this problem, so 16, but in our original problem, do you have more negatives or more positives? More negatives. So your final answer should be what kind of a 16? A -16. And those are just some strategies for you to think about if you're working some stuff out in your head, okay? But if you look at that and you're like, well, I don't know what -21 plus 5 is, what should you do? Grab a calculator, well, think, right? Yeah. Or grab a calculator, right? If you're like, nope, negative's not, maybe you're doing a test, right? And you're like, I don't want to guess. Don't guess, grab a calculator. Okay. Yes, yes, yes. Yes, I encourage you guys to use a calculator. Only because I'm much more concerned with you being able to solve the problem than it being like, oh, well, Jaden messed up a negative sign, like we got bigger fish to fry. It's important for that, but those little things you'll get better at the more we do math, Okay, so we good with those? Those still in our brains from the other day? You good? You following us, Corey? Okay. So now we're going to talk about writing equations. Typically, we would have already spent some time on this, but yesterday we had a short class, so I tried to keep our notes short. So writing equations means we're going to be given some verbal phrases, and we need to write the equation that represents them. Like if I'm talking, if I say x plus 5, right? You know, when I say x plus 5, kind of like an image pops in your head and you know what that looks like, right? You write your x, your plus sign, and your 5. But sometimes there's a variety of vocab we could use, right? So maybe I don't say plus, maybe I say more than. If I say that Asia has $5 more than me, right? Wouldn't I take the amount of money I have and then add 5 to it? Right? So words sometimes have more, or like adding, subtracting, multiplying, dividing, sometimes there's additional vocab for them. So that's what this table is going to have us look at. So if I'm talking about words like more than, plus, greater than, in addition to, and sum, SUM. What operation are we talking about there, Dallas? Addition. Yeah, these are words that mean add. Well, my stylus occasionally likes to have a conniption. Don't know if you ever noticed that. Come on, you can do it. And we're back. Okay. Words that mean add. Good. More than, plus, greater than, in addition to, some. What about less than, subtracted from, or difference? Asia. That is subtraction. Sorry, I know I wrote that big. This is not, I'm not using my good stylus right now. My good stylus is glitchy. Words that mean, what if I say product multiplied by or times? Alex? Well, if I say product multiplied by or times, does that mean addition, subtraction, multiplication, or division? What'd you say? Yeah, multiplication. Yep, multiplication. Words that mean, what if I said quotient divided by, we're actually going to add another one to that. Split, right? If I split a pizza into 8 parts, Lynn, divide. Good. Words that mean equals, equivalent to, the same as, or is. What symbol would you use if I said something is equivalent to something else? Lynn? Yeah, it's an equal sign. Yeah, words that mean equal. AKA just use your equal sign, right? Is one that we see a lot. If I say the sum is 7, that means equals 7. Okay. Are a lot of these words familiar? Okay, excellent. So for our next set of examples, we're going to turn some verbal phrases into mathematical equations. And the thing is going to be to look for keywords. And we're going to be like highlighting and things like that with those keywords, okay? So if you're someone who likes highlighting and such, if you have highlighters, you can get some out. So this first one says 10 more than a number x is 3. So the first thing I like to do in here is I like to identify my numbers, and I like to identify what I call math action words. Adding, subtracting, right? If I say sum, difference, less than, more than, those are math action words. It's telling you to do something. So first, let's just identify our numbers. I'm going to highlight our numbers. What are some numbers you see in 1? Alex? 3, negative 3, yes. What else? Dallas? 10. What else? There's another one. It doesn't look like a number, but it is. Jaden? That's going to be a math action word. Yeah, X. X isn't a number right now, but is it representing a number? Yes. So we know our equation has to have a 10 in it, an X in it, and a negative 3 in it. So then let's go from there. Now let's see what math action words. we see. So words that could mean more than, less than, or like add, subtract. Asia? More than. What do you think more than means? Dallas? I'm sorry? Add, yeah. If you see more than, that means add. Where's there another math action word? Asia? Is. What does is mean, Asia? Equals. Good. So once we've kind of dissected this, do we know we need a 10, right? We need a plus sign, we need an X, we need an equal sign, and we need a -3. Nice thing about these is they tend to kind of go in the order you read them. There are some exceptions. Subtraction is an exception to that. But this is saying 10 more than a number X is 3. So that means, and when you write addition, does the order you write addition in matter? Does 5 plus 3 mean the same thing as 3 plus 5? Yes. So who has an idea of how I could start to write this? Dallas? Yeah. In 1 second. So yeah, we would have 10 plus X. Good. Would it be okay if I wrote X plus 10? Absolutely. And then Dallas, what else did you want to say about this one? Yeah, equals -3. And this is all it wants from us. Could we then solve that if we wanted to? Yeah. On your homework, you have to solve them. For right now, I just want to focus on writing these down. Okay. All right, let's look at number 2. 7 less than a number X is equivalent to 12. So who can identify some numbers for me? Asia, tell me one number. 7. Someone else, another number. X. 12, yep. And the last one, X. Yep. So we know we're going to have a 7, an X, and a 12. Where are our math action words? Lynn? Less than, yeah, and is equivalent to? Good. Less than means we're going to do what? Subtract, and equivalent to means? Equals, yep. Good. Now, got another question for you. When you subtract, does order matter? Yes. 5 minus 7 is not the same thing as 7 minus 5. So if I write down 7 minus X, does that mean the same thing as X minus 7? No. So it's going to be really important right now to look at our words. 7 less than a number X, right? So if I say Lynn has 7 less pencils than I do, right? That means whatever pencils I have, you subtract 7. So with a situation like this, the 7 has to go on the back. So you would have to do X minus 7 equals 12. Because if you did, you paying attention, Jaden? How about you, Corey? You look like you're zoning out over there. You got this written down? Okay. So the reason is if you had X minus 7, you're going to get a different number. So you got to pay attention to the wording there. Okay. Questions about those? All right. Number 3, the quotient of a number X and 8 is 3. Who can point out some numbers for me? Asia. X. Jaden. 8. What else? 3. And where are my math action words? Jaden. Yep. Yep, quotient and is. Good. What's quotient mean? Asia? Divide. Yeah, and is means? Jaden? Equal to, yep, equal sign, exactly. Okay, so again, this one, if we're just reading it from left to right, isn't our division sign first? And if you're writing your equation, are you going to put a division sign first? No, it needs to go between two numbers, right? What two numbers is our division sign going to go between, Dallas? X and 8, yeah. So we're going to say X divided by 8 equals 3. It does with division matter if you swap it. Yes, if it says with quotient, I would tend to go in like the order it's stated. If it said the quotient of X and 8, do X divided by 8. If it says the quotient of 8 and X, do it the other way. Could you write this a slightly different way though? Is there a way to write it without like a division sign, Lynn? Yeah, if you prefer, you could do, I knew what you meant, don't worry. X over 8 equals 3 would mean the same thing, okay? That or is very sloppy. Oops, I'm like just drawing all over things. We're glitching again, guys. Maybe one day I'll have a nice tablet. That would be the day. All right, and then number 4, last one of these. So let's see here. We got the product of a number X and 9 is equivalent to 18. Where are my numbers at? Alex. Yeah, X, 9, what else, Alex? 18. Where are my math action words at? Bailey. Yeah, product of and equivalent to. Very good. Bailey, what does product of mean? So, yes, but do I mean addition, subtraction, multiplication, or division? You can look up at the chart if you want, if you're not confident. Yeah, multiplication. And you can put a little dot or put an X. I'm going to put a dot. 1, 2, put your equal sign. When you multiply, does order matter? No. So addition and multiplication, write them in whatever order you want. Subtraction and division, you got to be a little bit more careful. So if I want to write the product of X and 9, Corey, how do you think I could write that? Yeah. X times 9, and then what'd you put after that? Is means, what sign should I use? Equals, and then what number needs to go on the back? 18. Very good. Is this the only way I could write multiplication? No, you can put a little X if you want. You can put parentheses if you want. This is just the way I like to write it. This is a little strategy we use. I'm not a baseball fan, so this wasn't me. I didn't make up this Cubs W thing. Don't get mad at me. This wasn't me. This was a department thing. But it's a good little strategy to help you guys with your word problems, okay? So here's what we're always going to do. I always like to read through my word problem at least once first, okay? Then we're going to go back through and we are going to circle numbers in their units. We're going to underline the question. We're going to box our math action words. We're going to solve the equation, and we're going to write the answer in context. Now, when I say write the answer in context, if I want to know how much lemons cost, Lynn? Yeah, I definitely mean labels, and occasionally in sentences too. But the labels are the most important. But occasionally on standardized tests, you'll be asked to explain this and write it in a full sentence. So maybe you need to say, lemons cost 32 cents a pound, or whatever it is you need to write. Okay, so we're going to follow this strategy for a few of these, and there are 2 of them on your homework. It is for the in-class people. I can print out a copy of it for you though today. If you would like, I can do that. Sure thing. So the Mrs. Geyer. That should just say in Mrs. Geyer's first block class, but typing is not always my strong suit, guys. Sometimes I do these really fast. So the Mrs. Geyer's first block class has 2 more students than it did on Monday. There are currently 28 students in the class. How many people were in the class on Monday? So the first thing we need to do, I know that a lot of people can just read this and be like, oh, it's this many people. That's not quite the objective of this problem. The objective of this problem is to be able to dissect it, and we're going to define a variable, we're going to write an equation, and then we're going to solve it. If all you do is tell me how many people were in the class on Monday, you're not getting full credit on this problem, because I know that you can do 28 minus 2. That's not the objective. Okay, so let's go through and we're going to do what's called annotating our problem. So first we're going to circle any numbers and their units. So where do you guys see important numbers, Alex? Yeah, 28 students. And I like that you said 28 students and not just 28. Does anyone know why I like that he said 28 students, Jaden? Right. Labeling is important, and sometimes, especially when we get into more complicated problems, sometimes you'll be selling adult tickets and child tickets, right? Maybe sometimes money will be involved, right? There'll be a few different moving parts. What else is important? Alex? Yeah. In this case, there's 2 more students, and I think that's it number-wise, right? Does it matter that it's first block? No, it doesn't matter. Okay, so we circled our numbers and their units. We're gonna now box our math action words. Where do we see some math action words? Lynn? More. More means what? Add. And I think that might be it as far as math action words. I don't see an is or anything, right? Okay, so then what's our question? What are we being asked to find? Yeah, we gotta know how many people were in the class on Monday. So we're trying to find the number of people, right? So first step is to define our variable. You're gonna figure out your variable based on the question part. And the question is, how many people? So what could we use as a variable? Alex? Sure, X, and X is gonna stand for, yeah, the number of people. Do you have to use X? What else could you use? K. What else could you use? P. You can use any letter you want, right? Well, I wouldn't use a 6. That could get confusing. Use a star if you want, right? I don't care. But I personally like to pick a letter that makes sense with the problem, because sometimes eventually we're gonna be doing problems that have multiple. I want to make sure something real quick. Yeah, people at home, can you still hear me? Okay, good. I just had like a panic attack thinking that maybe I muted them. Okay, but yeah, you can use X, but yeah, I think I heard you, Alex, say sometimes we're gonna have multiple variables, and so it helps me, for me, it helps me keep track of them. So I'm gonna say that my variable here is P for people, and we gotta define it, which means say what it stands for. So P equals number of people. Maybe you want to use S for student, right? Whichever. I sometimes try to avoid using S because sometimes it looks like a 5, depending on your handwriting. Okay. Now we're going to write an equation. So we're going to now do what we did on that front page. There are 2 more people than there were on Monday, and the class is currently 28 students. Any ideas of how we could maybe write that there are 2 more people? Dallas. Very good. 2 plus P equals 28. How else could you write it? P plus 2 equals 28. Either way, because you're taking the number of people that there were in class, right? And you're adding 2 to it. And currently, there are 28. So that's why it equals 28. So now we're going to solve. What would we do to solve this? Alex? Well, so what would we want to get PL by itself? That's what we're trying to solve for. So what should we do with the 2? So we want to cancel it though. So right now, isn't it a positive and you're adding it? So how would you get rid of adding it? Yeah, you would subtract it. So subtract 2 from both sides, good. So P is going to equal, what's 28 minus 2? 26. Good. So now 26 what though? Students, people, I would accept either of those, okay? So 26 people. You don't have to define it there if you don't want, because don't we already know that P stands for number of people? Okay. But then it says write your answer in context. So what I want to see then is as a statement. Okay, if I ask you to do that, I'm asking for a sentence. Yeah, there were 26 people in class on Monday. Oh, this one's still glitching. Doesn't like me. So there were 26 people in class on, oh, whoa, sorry. It like, my wrist accidentally touched the zoom out and yeah, so technical difficulties, guys. There we go. In class on Monday. I need to get like an iPad or something so it's a little bit nicer. Maybe one day I could make a GoFundMe. Yeah. All right. Number 2. Are we good so far? People at home, are we good? Okay. Word problems are tricky. That we're gonna do them a bunch throughout, so you guys get used to them. All right. Number 2. The temperature outside is 15 degrees less than it was yesterday. If it is currently 80 degrees outside, what was the temperature yesterday? So let's go through and annotate. We're going to circle our numbers. Corey, where are there some numbers in this problem? Yep, 15 degrees. Where else? And 80 degrees. Good. Where do we have some math action words? Asia. Where do you see is? Oh, the is currently? Like that part? Yeah. Is currently means equals, right? Good. Jaden? Less than. Yeah, less than means subtract. And I think that's it. Yeah. That's probably it. You could look at that first is, right, if you wanted instead and call that equal sign. Regardless, we know we're going to have an equal sign. Right. So let's define our variable. Sure. We can use D for degrees, T for temperature, whatever you want. Oh, and I forgot. What's our question? What are we being asked? Yeah, what was the temperature outside yesterday? Okay. So you could use D for degrees, T for temperature, whatever. Jaden said D for degrees, so that's what we're going to use. D equals degrees. our temperature. So write your equation. This one's going to require some subtraction, right? When you subtract, does order matter? Yes, so you got to be careful with your order here. So we know sometimes it's nice to work backwards a little bit. Currently, it's how many degrees? I think I heard someone say it. 80, yeah, currently it's 80. So what's the end of our equation going to look like? What's this going to equal? 80. So we could start there if you want. So we know it's going to equal 80, right? We know that. How did we get there though? Well, we had a temperature, and didn't our temperature go down 15 degrees? Jaden, you have an idea? You're so close. You're so close. The only issue with that is, was it originally 15 degrees? No, it went down 15 degrees. D minus 15. It was a temperature, whatever it was, and it went down 15 degrees. So you got to take your original temperature first and subtract 15 from that. Does that make sense? Lynn, do I have you on that one? Okay. So what could I now do to solve? Dallas. Yeah, add 15 to both sides. And what was our past temperature then? Dallas? D equals 95 degrees. And how could I write that in a sentence? Asia? Yeah, sure. Yesterday was 95 degrees. You could say the temperature yesterday was 95 degrees. A lot of different ways to phrase that. So yesterday, it was 95 degrees. Perfect. Questions? Are we kind of seeing the strategy though to apply to these? Okay. They're not, people tend to struggle with word problems, and I know that, and we're gonna work on them. We do them quite often. Okay, so don't be afraid to ask questions on these. This? Well, this is actually like, because sometimes they're not quite this easy to figure out in your head. And so for when we get to those ones, you have to know how to set up the equation. Oh, and I was like, well, and I was like, these are actually, you're going to use, people have to figure out the temperature and stuff all the time. But like, remember when Alex said sometimes there might be more than one variable? When we get to those, you can't just do them in your head. You have to know how to set them up. And the strategy you use to set them up is the same. So we're starting with easier ones for it. Does that answer your question? Okay. And then last one. Mrs. Geyer, student 8 is making a sign for the classroom. The length of the sign is 3 times the width. If the length is 33 inches long, what is the width? So let's go through and annotate. Oh, and the reason we do it, to further answer your question, Jane, the reason we go through and do all our circling and stuff like that is because that's where people mess up in these. They miss important information. So we got to know our important information. So numbers. Where are my numbers? Alex? 33 inches. Yeah. And 3 times. Where are my math action words, Jaden? Times. Yeah. Times means multiply. What else? Asia? Yeah. Yeah, you can either, and you can, there's is in a few different places, right? But there is and is right there for equals, right? So that tells us our equation will equal 33. Okay, so let's define our variable. Oh, actually, what question are we being asked? What is the width? So if we're being asked, what is the width? What are we trying to find? The width. Sure, let's call it W. So W, is a sloppy W. So W equals width. Okay, and this is in inches. So let's write our equation. Again, if you get confused about it, well, I don't know exactly what has to go in the front. We know we have this little part there that says is 33, right? So what's our equation gonna have to equal? 33. So we know it's gonna equal 33. Sometimes it's easier to start with the end, right? And then fill in the front. Okay, well, we have the length of the sign is 3 times the width. So 3 times the width. And width is what letter? W. How could I maybe write that? 3 times the width. Jaden? 3 times W, right. 3 times W equals 33. Exactly. Because this says exactly 3 times, W stands for width, is equals 33. Then what could I do to solve? Dallas? Yeah, divide by 3. And what's 33 divided by 3? Oh, I didn't put X. I don't know. 33 divided by 3, Jaden? 11. Yeah, so W equals 11. 11 what? Inches. And then someone tell me, how could I write this in context? Asia? Very good. The width of the sign is 11 inches. Excellent. Good.